In this second video, we're going to discuss the different nutrients and components that are found in food to help fuel our activities and our growth. We enjoy eating food for so many reasons, because of its taste, smell, the pleasure and comfort it gives us. However, we rarely stop to think about what our food actually contains. Foods are composed of many chemical substances, some of which are useful to the body and others are critical to human growth and function. Those that are critical to human growth and function are called essential nutrients. There are 6 groups of essential nutrients found in our food: the vitamins, lipids, water, minerals, proteins, and carbohydrates. We can separate the 6 nutrients into 2 main groups. First off, we have the macronutrients. The word macro means large. We call these nutrients macronutrients because we need to consume them in relatively large amounts to support normal function and health. These 3 macronutrients provide us with energy. You might be familiar with carbohydrates, for example, the primary source of fuel for the human body. If you look closely at the word carbohydrate, it reveals its chemical structure. Carbo refers to carbon. Hydrate refers to water. If you remember, water is composed of both hydrogen and oxygen atoms. Thus, carbohydrates are made of carbon, hydrogen, and oxygen. Lipids, also known as fats and oil, is another important source of energy for the body. It's an important source of energy during activities of low intensity, such as rest or during sitting, listening to this lecture. Like carbohydrates, lipids are composed of carbon, hydrogen, and oxygen. But food-containing fats also provide fat-soluble vitamins and essential fatty acids, which we'll discuss on the chapter on lipids. The last macronutrient is proteins. Proteins also contain carbon, hydrogen, and oxygen, but they're different from carbohydrates and lipids because they also contain the element nitrogen. Proteins are the building blocks of human tissues. They also provide energy, but they mainly support growth, repair, and maintenance. Vitamins and minerals are called micronutrients. The word micro means small because we need to consume them in relatively small amounts. We won't go into too much detail, but you can separate vitamins into 2 types. They're either fat-soluble or water-soluble. And that really talks to where in the body they are stored and where in the body they are used. If they're fat-soluble, that means they're stored usually in adipose tissue. If they're water-soluble, they usually travel in aqueous environments, such as the bloodstream, for example. So you have vitamins A, D, E, K in the fat-soluble category, and C and B vitamins are in the water-soluble category. Minerals, we separate them into either major minerals or trace minerals. Major minerals are minerals that you need in amounts greater than 100 milligrams per day. Trace minerals are minerals that are needed in amounts of less than 100 milligrams per day. Water is the last of the nutrients. It's an inorganic nutrient that's vital for survival. As you know, we consume water in its pure form, in juices, soups, and other liquids, and solid foods even, such as fruits and vegetables. You need adequate water intake to ensure proper balance of fluids both inside and outside of our cells, and also to assist in regulation of nerve impulses, body temperature, muscle contraction, nutrient transport, etc., etc. Clearly, it plays a key role in our health. Now that you are familiar with the 6 nutrients, we should discuss these dietary reference intakes. In the past, dietary standards were set with the goal of preventing nutrient deficiency diseases. As you can imagine, in developed countries like Canada and the United States, these diseases are now extremely rare. So these new dietary reference intakes are aimed at preventing and reducing the risk of chronic disease and promoting optimal health. So basically, these are standards to help identify how much of each of the nutrients you need to consume. They're based on reliable and valid research. There are many of them. They all mean something slightly different. So why don't I walk you through each and every one of them so that you can be more familiar with these uses. So dietary reference intakes is an umbrella term for all of the standards that guide us in the adequate consumption of a nutrient. The first one we can discuss is the dietary reference intakes. The dietary reference intakes are related typically to micronutrients. DRs for energy and macronutrients are specific to macronutrients. Let's start with the estimated average requirement, so the EAR. You can go to page 17 in your textbook to get a good idea of what estimated average requirement represents. It's basically the average daily nutrient intake level that meets the requirements of half of a healthy individual group. So if everyone is represented, the whole population of the world on this curve here, you'd have some people that require less of a nutrient on the left-hand side of the graph, and some people who require more of the nutrients to stay in optimal health. But the average to cover 50% of the population needs, this is the value of the nutrients you would need to consume. So if we're talking about calcium, perhaps this is the amount of calcium that would be adequate for 50% of the population. Now obviously we don't want only half of the population to stay healthy. So we have another standard, the Recommended Dietary Allowance, or RDA. It's the one we use most commonly. That is the average daily nutrient intake level that will meet the requirements of almost all healthy individuals in a given stage or gender group. So it'll cover 97 to 98% of the population. If 98 to 97% of the population consume this amount of the nutrient, they will stay healthy. RDAs are used more commonly than estimated average requirement because estimated average requirement will only cover the needs of 50% of the population. Because nutrition is such a new science, we don't actually know what the RDA is for every nutrient. So sometimes we need to rely on adequate intake. Adequate intake is the recommended average daily nutrient intake level based on observed or experimentally determined estimates. So in this case, they're only estimating what should be consumed. For example, vitamin K and fluoride have AIs, adequate intakes, instead of RDAs. Tolerable upper intake level is the highest average daily nutrient intake level likely to pose no risk of adverse effects to almost all individuals. So that's the most you should consume of the nutrient that we're talking about. Okay, a little recap. Estimated average requirement will fulfill, it's a value that will fulfill the needs of 50% of the population. RDA is the value that will cover the needs of almost all of the population. Adequate intake is the minimum you should take. Tolerable upper intake level is the maximum you should take of a nutrient. Okay, let's talk a little bit about macronutrients. Estimated energy requirement is defined as the average dietary energy intake that's predicted to maintain energy balance in a healthy adult. So that value, the estimated energy requirement, how much energy you need in a day, 2,000 calories, 3,000 calories, will vary depending on a person's age, gender, weight, height, and level of physical activity. For example, equations have been developed to help establish how many calories a person might need in a day. If you want to hit pause and take a moment to fill in the values for you specifically, you can calculate how many calories you will need. This first equation will just tell you how many calories you need just to stay alive. If you were to lie still all day, how many calories would you be burning? The equation is different depending on whether you're a man or a woman. Go ahead, fill in the equation. Once you've found your value, you can multiply that number by the conversion factor that best describes you. Do you sit all day? You might be sedentary. Do you participate in light sports, perhaps gardening or walking? Maybe you have a light activity level. If you're training for the Olympics, perhaps you're in the exceptional activity level. Once you've found which activity level best describes you, multiply the value from the equation to this conversion factor, and that should give you the number of calories you would need to maintain an energetic balance. Now, the acceptable macronutrient distribution range refers to carbohydrates, lipids, and proteins. It basically tells you how many of your total calories that you just calculated with your EER will need to come from carbohydrates, how many would need to come from proteins, and how many would come from lipids. We'll get into this in a bit more detail during your assignment, but carbohydrates should be 45 to 65% of your total energetic consumption. Lipids should be 20 to 35% of your total energetic consumption, and protein would be 10 to 35%. This will vary a little bit depending on your activity level and the type of activity you engage in.